to please switch off your mobile phones or keep them on the silent mode if they are very urgently required. I request you all to please settle down and take your respective seats. And I request Mr. Vipin Tyagi, Executive Director CDOT, and Ms. Dorothy Stanley, IEEE 802.11, Working Group Chair, to please take their respective seats on the dais. Ladies and gentlemen, namaskar and a very good morning to all of you. I once again welcome you all to CDOT's 36th Foundation Day celebrations and the Technical Conference on the Future of Telecom Technologies and 1M2M, the Global Standards for IoT M2M, being organized by CDOT and European Telecommunications Standards Institute ETSI under the aegis of European Union-funded project on India-EU cooperation on ICT-related standardization, policy and legislation in association with Telecommunications Standards Development Society India, TSDSI. Today marks the second day of the conference, wherein we will have detailed deliberations on a wide range of subjects, including the standardized implementation of smart cities and various security aspects and use cases related to the M2M IoT domain. We extend a very hearty welcome to all our guests and dignitaries for their gracious presence at the event. I would also like to remind you that we have staged an exhibition outside the auditorium showcasing the live demonstration of CDOT's cutting-edge technologies and innovations, along with the 1M2M compliant applications developed by CDOT and its ecosystem partners. The exhibition can be visited during the breaks. All the information and updates about the conference are available on our website www.cdot.in under the section Latest Updates. We'll stay connected with our friends and colleagues at our office in Bengaluru too. We also extend a hearty welcome to all our guests in Bengaluru. We are privileged to have in the midst of us Ms. Dorothy Stanley, who's a Hewlett-Packard Enterprise Fellow and the head of the Standard Strategy at Aruba, a HPE company. She currently serves as chair of the IEEE 802.11 Working Group. She is also chair of the IEEE 802.11 Task Group, responsible for maintenance and revision of the 802.11 standard, and has chaired various wireless network management task groups. She has served in numerous leadership roles in Wi-Fi Alliance and is co-chair of the IETF IEEE 802 Coordination Committee. Previous to joining Aruba Networks, Stanley was a consulting member of the technical staff at Agere Systems for Waveland products and a distinguished member of the technical staff at Lucent Technologies and AT&T Bell Labs. Her responsibilities included system architecture, software development, and capacity and performance analysis for digital switching systems and fixed wireless systems. Among Stanley's awards are 5 patents, a WFA Members Achievement Award, WFA Special Recognition Awards, and IEEE Standards Association Awards for contributions to numerous IEEE 802.11 standards. It's a pleasure to have you here, ma'am. May I now request Mr. Vipin Tyagi, Executive Director CDOT, to formally welcome Ms. Dorothy Stanley, IEEE 802.11 Working Group Chair, with a potted sapling and an Angavastram. We extend a very hearty welcome to you, ma'am. Before we listen to Ms. Stanley, I would like to request Mr. Jayant Mandal, Team Leader CDOT, to give a brief introduction of the subject matter.
Good morning to Ms. Dorothy Stanley, guests from the telecom fraternity, C-Dot licensees, C-Dot board members, my friends and colleagues of C-Dot. It's really a privilege for me to introduce about the Wi-Fi 6. Year 1999, Wi-Fi was born, and this year world is celebrating 20 years of Wi-Fi. Wi-Fi today is the household name synonyms with the delivering high capacity wireless devices that are used to support the vast majority of smartphone users. The cost effective technology coupled with the open ecosystem together with the ease of upgrade that ensure backward compatibility for all the deployed Wi-Fi devices has created an astoundingly successful market, which last year saw the deployment of over 3 billion new Wi-Fi devices. However, the Wi-Fi industry is not resting on its laurel. It is not complacent about the ability to continue to help support the tsunami of mobile data. With 802.11ax, or commonly called as the Wi-Fi 6, the Wi-Fi industry is introducing not just the next generation of Wi-Fi, not just the set of increment in terms of the better throughput or coverage that improve all existing deployment, but fundamentally new set of capabilities which can be used by the industry to address the whole new set of opportunities. Wi-Fi technology has shown a continued evolution both in terms of features and throughput. 11ax carries on this progression, delivering improvement over the existing 11ac feature set as well as introducing the number of significant new capabilities. These enhancements to Wi-Fi capabilities are occurring at the same time the cellular ecosystem is defining the evolution of its wireless access system targeted at supporting the 5G requirement laid down by ITUT for IMT 2020. These IMT 2020 requirement targets improvements in spectrum utilization, achievable data rates, and other characteristics for 5G radio access relative to previous generation of wireless technology. With 11ax, Wi-Fi is well positioned to address all these critical aspects. The new 11ax capabilities can be used by the service provider to deliver 5G use cases in a very cost efficient manner. However, already leveraging free, global, and widely available spectrum at 2.4 and 5 GHz, Wi-Fi and 11ax is set to benefit from the new spectrum allocation in 6 GHz to support the future scaling requirement of wireless system. Wi-Fi 6 or IEEE 802.11ax is the latest standard in the wireless LAN, and the scope of this project states that the amendment defines standardized modification to both IEEE 802.11 physical layer and the 802.11 MAC layer that enable at least one mode of operation capable of supporting at least 4 times improvement in the average throughput per station in a dense deployment scenario while maintaining or improving the power efficiency per station. This amendment defines operation in the frequency band between 1 GHz and 6 GHz. This amendment shall capable of backward compatibility and coexistence with the legacy 802.11 devices operating in the same band. 11ax is focused on improving performance in a dense environment by targeting at least 4 times improvement in the per station throughput compared to the 11an or 11ac. Improved efficiency through the spatial stream, that is multi-user MIMO, and the frequency OFDMA multiplexing. Dense scenarios are characterized by the large number of access points and large number of associated stations deployed in a geographical limited region like the stadium or airport, etc. 11ax supports the target wake up for IoT low power use cases, efficiently address the improvement of device battery life. With the support of 1024 QAM, we can achieve a very high throughput application which requires the multi-gigabit of speed. 11ax supports OFDMA uplink and downlink, which improve Wi-Fi performance in a high density, high throughput environment like stadium or auditorium. In 11ax MIMO, Uplink serves up to the 8 users simultaneously for a significant capacities boost, especially for the large venue like railway station or fairs, etc. Also, 11AX supports the spatial reuse or color code to mitigate collision between the signal from the nearby network, and it supports a new frequency of 6 GHz enabled to use around 1.2 GHz spectrum in a 6 GHz band and very suitable for the high throughput applications. Today we all have the opportunity to hear from IEEE 802.11 Working Group Chair Ms. Dorothy Stanley. She is the leading force behind the tremendous progress in the 802.11 standard. Now I welcome Ms. Dorothy to enlighten all of us. Please.
Good morning. Testing, testing. Okay, is that good for the audio? Sometimes it's a little quiet. First of all, thank you so much for the invitation to come and speak today, for the kind introduction. It's my honor and my pleasure to be here to acknowledge the celebration of the many, many years of the CDOT organization's successful contributions to India and the Indian economy. And again, my delight and my honor to speak about 802.11 and the work that we have ongoing as we look forward to continued development of the standard. My talk is in 3 parts. The first, I'll give an overview of the area that the structure in which we do our standards development. So I'll provide an overview of IEEE 802, the IEEE development process, a very brief description, and then the 802.11 working group and the projects that we have ongoing. Second part, we'll talk about 802.11ax and some of the amendments under development. If you walked through the exhibition area, you saw that CDOT does indeed have an 802.11ax product. So obviously there are a lot of people here who are very familiar with that and the technical capabilities. So we'll go through those very briefly. And then we'll talk about 802.11 and 5G. I get this question all the time. Well, Dorothy, you know, how does 802.11 fit with 5G? So we'll talk about that for a little bit. Okay. So first, the standards development infrastructure. There are many standards development organizations globally. We have ISO IEC, JTC1, we have the 3GPP or the ETSI process, we have IEEE, we have a number of other country-specific standards development organizations. The development of IEEE 802.11 is obviously within IEEE. Within the Standards Association, there are 2 paths for possible standards development. The first is the individual process, and this is the development process that's used for 802.11. So by individual process, we mean you don't have to be a member of a company, large or small, pay hundreds of thousands of dollars in membership fees. You can participate. You come to the meetings and you participate. The Standards Association also does offer a corporate membership model. So if there are companies that want to come together and develop a standard, they can do that also. The statistics currently, right now, there are on the order of 7,000 individual members of the Standards Association. There are on the order of 200 member companies as far as standards development. In terms of numbers of participants actually developing standards across a broad range of technical capabilities, from power and energy systems to biomedical devices to blockchain and other emerging technologies, there are on the order of 20,000 participants who are involved in the IEEE standards development process. The rainbow circle at the your right gives the a highlight or the summary of the processes that are followed in development of a standard. First, a project is initiated. So you have a group of people who come together and decide they want to define a project in a new area. So you document that in what's called a project authorization request. You identify a working group where the work will be done. Then the standard is drafted. In our particular process, we have 2 balloting phases. The first is within the working group, and the second is at the SA level. At the SA level, the IEEE also has a public review process. So anyone globally can participate in that public review. So there's an IEEE webpage where there's a list of all the standards that will be coming up for public review. You can sign up and get that standard and provide your comments. So it's totally open. I'd encourage you to look at that, if for no other reason, not necessarily .11 specific, but the whole range of other standards that are being developed. It's a great educational opportunity, at the very least, just to learn about technologies under development. And then, of course, there's gaining final approval. Now, all of this is great and wonderful. The proof in the pudding really is the standard deployed and used and implemented? And we're very fortunate, really, with .11 and a number of the 802 standards where we have exceptionally wide deployment and use and interest and societal impact. So that's the overall process, IEEE Standards Association and product and standard development. Now we'll come one level down to the 802 Landman Standards Committee. So at the IEEE level, there's the Standards Association. And then a level down from that are multiple standards committees where the standards development actually takes place. Ours is within this Landman Standards Committee. Our peer working groups in that in 802 are listed here. So you see 802.1, 802.3, and these are the 2 that I'll highlight along with the others. 802.15, wireless specialty networks is where the base technology for products and technologies in the market such as Zigbee are defined. The focus of the 802 group is really on the MAC and PHY layers. So we depend on the IETF for the upper layers. We really focus on MAC and PHY. I think this is another attribute of our success in leveraging all of the data networking work that's been done in the IETF across a multitude of applications. So products don't have to reinvent the wheel. They already have all the data networking stack for other purposes, and we just reuse it on top of our MAC and PHY. Currently in 802.11, we have on the order of 300 working group members. So these are individual participants who vote on and contribute to development of the standard. The numbers are similar for 802.3, Ethernet, and slightly lower for the other groups. So I'll talk ever so briefly about 802.1 and 802.3, and then we'll go into more detail on .11. So 802.1, the reason I want to highlight 802.1, they've done a lot of great work in the past for architecture, for quality of service, for bridging. They're a very, I think, industry area of interest that they're currently working on is time-sensitive networking. They have a number of standards that have been published. The market interest in these standards is to support the Industry 4.0 initiatives, where you're looking at factory and other business manufacturing applications where the requirements on data and data processing are much more stringent in terms of latency and delay and reduced jitter. So they have developed a number of standards to support these types of time-critical or mission-critical applications. I've provided a number of links here, so you'll have those for more information. The current time-sensitive networking standards are based on Ethernet and targeted for a number of applications, including automotive. What we're discussing now, we're discussing in .11 with TSN, how can these standards be applied over .11 networks? And this is an area of new work for us. 802.3, this is the Ethernet working group. Everyone, I'm sure, here is familiar with Ethernet. What I've provided here is a list of the standards that are currently under development within Ethernet. About 5 years ago, there were some folks within Ethernet that thought, well, we have all the standards defined. We've got PoE, we have high rates, we have low rates. We think we're done. Well, guess what? They were not done. There are so many new applications coming that have specialized requirements. There's a significant amount of work ongoing in 802.3. One particular application area is automotive. That there's a tremendous amount of work being done for new Ethernet standards that can be deployed in a car, basically to replace over the long term the wiring harness infrastructure that exists in the most cars today. The market motivations are more fuel efficiency and reduced weight. And eliminating the existing wiring harness goes a long way to meeting those market objectives. So I encourage you to, as much as 802.11 is doing on the wireless side, there's a tremendous amount of work going on in 802.3 on the wired side. Okay, so that's IEEE 802, briefly .3 and .1, and now we'll look in more detail at 802.11 and the work that we have ongoing here. So we have several types of groups. The overarching one is the 802.11 working group. We have standing committees, which are ongoing, task groups, which are focused on specific amendments, study groups, which look at new work areas and identify specific areas of work to move forward with, and then topic interest groups and ad hoc groups that are more exploratory in nature and investigate topics, look at topics to determine whether or not additional work should take place within the working group. Oh, okay. No. Okay. So this is the current situation of the active groups that are ongoing. So we have the working group itself and various infrastructure subgroups. This is what I refer to as kind of keeping the lights on in the working group. Even if you had one task group active, you would probably have these other groups ongoing to identify whether there's new work and to interface with other organizations. So we have an architecture standing committee that looks at the overall architecture of .11 and our interface with .1 to make sure that stays in place. As we develop new amendments, for example, we'll talk about .11BA, which is a wake up radio project to look at reduced power consumption. We introduce new entities into the architecture, and we need to make sure that the whole overall architecture remains consistent. So there are discussions related to that in the architecture group. We have a coexistence standing committee that we formed primarily to look at coexistence of our technologies, .11 technologies, and the 3GPP developed unlicensed technologies to make sure that when both of those are brought to the market, both can perform well, and that's our goal. In July, we hosted a coexistence workshop in Vienna, and I can provide you the links to all this, all the presentations, everything are on the website and publicly available. The Power Review Standing Committee looks at other projects that are being proposed in 802 for common review. The JTC1 Standing Committee, this is at the 802 level, but we take care of the maintenance of it. The official international stamp of standardization is provided by ISO IEC JTC1 SC6. So we have official standing in that regard over and above our IEEE standing and market adoption, so that the regulatory barriers to adoption of our standards are very low. So that's the goal of that group. Finally, the ANI group, Advanced Access Networking Interface, these folks have been looking at our interfaces and the analysis of how 802.11 systems meet 5G requirements. And I'll talk more about that later. Then you see the new work areas and the amendments and revisions that are underway. And we'll talk more about those. Okay. As the introductory speaker mentioned, the development of the .11 standard has been going on for quite some time. Wi-Fi as a brand name was officially introduced in 1999. Prior to that, there was a standard published in 1997, the 1 and 2 megabit standard. You can see that over time, we've had orders of magnitude improvements in throughput and capacity across the various spectrum bands. And so these are shown here. The initial standard was in 5 gigahertz was 11A. The initial standard in 2.4 was the 1 to 2 megabit standard, and then the .11 11B standard in 1999. Since then, we've added applications in 60 gigahertz, the first standard being 11AD, and 11AY coming shortly. Oh. Okay. So this is the history, and this is the current working view. So we have a number of published amendments. These are amendments for which the development work has completed. They've been ratified. In many cases, development and implementation is ongoing. So these would be 802.11aq, which is pre-association discovery, 802.11ak, general link, 802.11ai, which is FILS, or fast initial link setup, 802.11ah, this is a sub 1 gigahertz amendment, and 11aj, which is a China millimeter wave standard, looking at how to extend 11AD mechanisms so that they work in the reduced bandwidth that's available in China. Right now in 11MD, we're in the process of rolling in these amendments onto the base standard. The current base standard is 2016. We expect a new base standard to be published in 2020. And then you see the amendments under development. Next generation positioning, wake up radio, high efficiency wireless, wireless LAN, and next generation 60 gigahertz. These are the projects for which substantial work is complete, that there is a draft available, that work is continuing on. Then we have task groups where there is not yet an approved draft, and it's very early stages. So the folks without an approved draft would be looking at, for example, channel models. If it's a PHY amendment, you'd be looking at use cases, at requirements. And we'll go briefly over some of these that might be of interest. The current topic interest group that is active is entitled Random and Changing MAC Addresses. And this group is looking at what is the effect on the network and on our systems of changing the MAC address and basically randomizing MAC addresses as devices come and get on the network. We're balancing, and we see in the industry and in society at large, trying to come to a balance between privacy and not being tracked, and getting service and having a system working. So there have been a number of initiatives that are aimed at preventing tracking. You have people that want to track people on a Wi-Fi system or any other system, and you have people that want to balance that with privacy and the legitimate requirements that end users have for their privacy. And so a number of vendors, particularly Microsoft, Google with Android, and Apple, have introduced randomization of MAC addresses so that is not an immediate identifier of a particular device. And so we're looking at what are the implications of that. We're giving recommendations on if you're going to randomize a MAC address, how should you do that? What other mechanisms and pieces of data do you need to randomize so that you will not be tracked? And this is an area of a lot of interest. The woman who's leading that effort, Amelia Andersdotter, her affiliation is Article 19, which is a nonprofit organization very interested in privacy concerns. Okay, so that's the high-level overview of the organization and the structure and the groups that are currently active. I'd like to talk now about, within that structure, what motivates new projects coming, and what drives the innovation that comes through the 802.11 standard as it's developed. There are really 4 areas that are driving the work that we do and where we get market input. The first is demand for throughput. You saw this on the summary slide that shows the progression of the standards over time from 11, say B to G to N, and now to AX. The demand for throughput, it's just exponential demand. We put out the capability, it gets used. And so this market need is what has driven 11AX, 11AY, and will be driving 11BE, which is a new project looking at the basic MAC PHY for 2.4, 5, and 6 gigahertz that comes beyond AX. It's a reality today that most, depending on the country that you're in, most of the world's mobile data is carried on Wi-Fi and 802.11 devices. This is not going to change anytime soon. There's such exponential growth for bandwidth that really all available means for transporting the data and carrying the data are required. The work being done in AX and coming in BE is being done to further enhance the .11 systems in a backwards compatible way so that more and more data can be carried. So that's demand for throughput. The next is new usage models. So here, for example, the focus on dense deployments, the need for enhanced indoor location capability for ranging, automotive. So 11P is the standard published some number of years ago that underlies the DSRC protocols and applications. We were criticized about at some point by others for not having an evolution path. So we have an evolution path, and that evolution path is being done in a group called 802.11BD. That's Bravo David. And so this is the automotive segment is one that we're doing work on for next generation V2X. And the goal here is to provide a backwards compatible way to extend and evolve the systems that are out there. And then, of course, low power IoT type applications, there are new usage models and extensions to existing usage models. So we have the market drivers. We also have the technology drivers. So new technology, as it becomes possible to develop and integrate in a cost-effective way, is being added to the standard. An example here, MIMO, which was introduced in 11N and 11AC and 11AY. OFDMA is the new addition in 11AX, which gives us improved performance over a number of areas. And then, of course, changes to regulation always drive us because we need to reach out in new markets where the spectrum is available, and we also need to respond to the regulatory requirements. Okay, so what I've discussed so far completes the first part of my talk. So we've had an overview of IEEE 802, a little bit on .1, .3, .11, the high-level structure. So I understand that my time here is about 1 hour. So there's not enough time to talk about all of these topics in any detail. What I'd like to do is focus first on AX and BE to highlight several points on those. Then we'll talk about support for the items that are coming regarding to 60 gigahertz and a couple of the use cases that are relevant there, particularly for fixed wireless access. And just to give you a little teaser or lead in there, I've heard the term frugal Wi-Fi, frugal 5G. Frugal 5G, that Wi-Fi is effectively a frugal 5G technology. And I believe that that's actually true, both for 5 gigahertz and 2.4 with 11AX, and for 60 gigahertz with both 11AD and 11AY. That you can have really a very cost-effective fixed wireless system with these 802.11 technologies that are coming. And so I have some examples of the use cases that are actually being deployed now with those systems. Okay, so, okay, 11AX. You're very familiar with this. The goal is to improve performance in dense environments. The top line goal in 11AX is to improve the efficiency. We do get some overall top line throughput improvement, but the main improvement is on the amount of data carried over the medium in a particular amount of time. So we're increasing the efficiency. The targets you've seen, the main mechanisms introduced are spatial MU-MIMO and OFDMA. As part of the conversation here yesterday, I told, well, you know, Dorothy, there are dense deployments, and then there's India dense, which is another level of density, and in terms of number of users that need to be served, and the throughput demands that are there. So I take that point. One example I'd like to highlight in terms of amount of data that's carried on a wireless LAN network, at the recent 2019 Super Bowl event, which is a huge sporting event in the US, the wireless LAN system, the 802.11 system in the arena, in the stadium, carried 24 terabytes of data over some small number of hours. So this is a very an optimized, engineered wireless LAN system in a stadium, a large stadium, but a stadium, carrying a tremendous amount of data. So today we can do that with 11AC. The goal is to improve that further with 11AX so that we get even more throughput and support even more users. And just follow this continuous improvement in terms of throughput as well as power efficiency. Okay. There are, in 11AX, the introduction highlighted a few of these features. I'll describe them really in 4 areas of improvement and really systematic and continued improvement of the .11 standard. The first is in spectral efficiency and area throughput. 1024 QAM, for example, 10 years ago, it wasn't possible in a cost-effective way to implement a 1024 QAM system and deploy it. It wasn't possible. Today it is possible because of the improvements in chip manufacturing and technology. So that is now deployed and implemented. Downlink, uplink, MIMO, increasing the number of clients that can be supported to 8 clients. So you can get an improvement in throughput there. And then the reduction in the the reduction in the overhead of the OFDM symbol duration so that you can get, again, more efficient operation on the medium. In terms of high density, OFDMA is a key feature that enables more users to be served at a particular moment in time. And I have a picture that will show that in more detail. And then power saving. Power saving and improved battery life are always needed, virtually always needed. I don't care how power efficient you are, the vendor will always, your downstream customer will always come to you and say, it needs to be more power efficient, right? And so we have a process of continuous improvement to reduce the battery consumption, reduce the power usage of our chipsets and our protocols. And there's a particular mechanism introduced here, it's called target wait time, to enable client devices to be, that their sleep schedule effectively is managed and known, so that they know exactly how long they need to sleep. And a sleeping client is a client that's saving power. So we want to increase the amount of time in that state. The final category of improvements is in outdoor and long range. Many Wi-Fi systems are deployed indoors, and that's the primary application. However, there are also many outdoor deployments where it's, for a variety of reasons, it's not possible to run power. You just need to you want to extend the range of your network so that a workforce or technicians can access the internet. So there are a number of technical changes made to enable further performance and longer range for outdoor applications. The particular mechanism that's shown kind of at the top here is duplication of certain entries in the preamble, so that the probability of a packet being received successfully is increased. So those are the 4 categories. Then let's look at just a couple of the mechanisms in more detail. The first is OFDMA. And so what happens here is the access point can really customize usage of the medium to the data needs of the client device. So in an OFDM system, each user has access to the medium over time, but only one user. In OFDMA, you can have multiple users using the same, in the same time space to use that frequency. So we're able to use, to serve more users, to really match the amount of bandwidth that they use to their needs. So the applications, for example, TCP, right? You have TCP AX. You don't need 100 megabits or 100 megahertz of spectrum to transmit a TCP AX. So now you can really customize and be very efficient for short data frames. Okay, so that's OFDMA. The next one, and here the idea is you can see pictorially the efficiency improvements for uplink data. So I call your attention to the yellow areas in the top line. So this is where data is being sent sequentially by a VHT or 11AC client device. So you see transmission and then the acknowledgement. Back off of the channel, transmission, and then acknowledgement. Back off of the channel, transmission, and then acknowledgement. So it's sequential, it's in series. With uplink and downlink multi-user, specifically for uplink data, you'll have this concept of trigger frames is introduced. So you have a single back-off period followed by a trigger or an indication, followed by multiple stations transmitting. Okay, so you have a large amount of data, and then you have the acknowledgements. So you can see that the duration of usage of the medium to transmit the same amount of data is reduced. This is increasing the efficiency. So at the end of the day, when you have more users on the system, the medium will still be occupied, but you're going to be getting more data through the system. Okay, a similar picture for downlink. okay? And then target wait times, again, I mentioned improvements in wanting to increase the lifetime of battery-powered devices, and that's really what this target wait time is intended to do, that you have scheduled sleep and wake times. Now, this feature, this target wait time feature, was initially introduced into the .11 standard via not 11ax, but 11ah. 11ah was published in 2016. It's the sub 1 gigahertz amendment that looks at defining a Phi and MAC features for much shorter bandwidths for IoT and sub 1 gigahertz applications. So as you can imagine, if you're talking about a standard that's targeted towards IoT, you really need very efficient power-saving mechanisms. So this was introduced in AH, and it's being carried forward now in AX. So it will apply then in the 2.4, 5, and coming 6 gigahertz bands. Okay, then 20 megahertz only clients. Again, the goal being support very low power, very low complexity devices, particularly targeted towards IoT, where those devices aren't going to be transmitting a lot of data anyway. You don't require them to, for example, listen on secondary channels. You just know that they're a simple 20 megahertz single channel device. All right, so I've highlighted a few of the features and capabilities added in 11ax. I want to talk about a characteristic of .11 systems, which is backwards compatibility. How do we achieve backwards compatibility? We have a common preamble across the Phi generations. So for example, in 5 gigahertz, we use the 802.11a preamble. So this is used in 5 gigahertz operation, whether you're using an 11a system, 11n system in 5 gigahertz, 11ac system in 5 gigahertz, or an 11ax system in 5 gigahertz. So, this is the technical mechanism which we think is just really critical, and it's provided us a key success factor in the marketplace. What is that key success factor in the marketplace? It's this backwards compatibility. You don't have to do a forklift upgrade of the entire system. You change out the access points, all of the prior generation clients continue to work. From a market penetration, a customer-friendly usage scenario, that is absolutely essential. And so this is the mechanism that we've used. Not only does it provide backwards compatibility, it provides a reduction in contention on the medium, because devices can detect and differentiate between just noise on the medium and actually a valid data packet, and then defer accordingly. So you have less contention and better good put on the medium. This becomes important when we start looking at coexistence with other systems. But anyway, so this is what the standard has done there, and it has has been very fortunate and productive for us. So 11ax. 11ax is shipping now. First of all, I'll go back. I'll just stay here. So 11ax. 11ax, you have a product. It's out in the back. HPE Aruba, we have a product. It's shipping now. Wi-Fi Alliance is developing an interoperability certification program for 11ax. That should be announced shortly. So very soon we'll see really a flood of 11ax devices in the marketplace. This is happening even though the 11ax standard is not yet finally ratified. All of the products that are in the market, well, I don't know about all, but at least ours, and the Wi-Fi certified 802.11ax devices will be based on 11ax draft 4.0. Draft 4.0 is the most recent draft that has been made available and made available for sale by IEEE. It is quite mature. So the expectation is that all of the products deployed will be compliant with the standard when it is eventually published. The reality of developing a standard and then getting product to market is when you're developing a standard, you have a lot of smart people in the room, right? And they all want their feature in there because they have a great idea. And those features are analyzed and debated and refined again and refined again. The end result is, particularly in our major Mac and PHY amendments, we have many more features in a standard or in an amendment that can reasonably be implemented by vendors in a particular product cycle. So the work that effectively is done by the Wi-Fi Alliance is a project management function of vendors coming together and saying, okay, what can we build that will meet market needs for a particular release? And that's why you see this release 1, release 2 scenario playing out, where the standard actual final ratification may be published at a certain point in time. And that's what's happening with 11ax. Okay, so that's the market situation with AX. So what will come after AX, we are just now starting to look at. And this is the 802.11be project, or extremely high throughput project. The throughput goals for 11be are to have at least one mode that supports 30 gigabit per second operation. Let's just think for a moment about how far away that is from the initial 1 and 2 megabit standard and the 11 megabit standard, right? It's not quite light years away, but it's a long way away. We've made such tremendous progress over the years. So higher throughput and also support for low latency communications. And this is where we're having the dialogue now with the 802.1 folks and TSN, the time-sensitive networking, to look at how can we apply those time-sensitive techniques that they've developed onto our wireless LAN system so that we can get those kind of performance numbers and closer to those performance numbers on a wireless system. The 11be amendment will operate in 2.4, 5, and then 6 gigahertz bands. You can see the target completion date here. As part of the study group discussion of this project, we also had some folks coming to us from the gaming industry who came and said, well, we really need low latency, low jitter, wireless communication to support gaming. So we said, okay, we're getting the market requirements and trying to do our best to respond to them appropriately. Okay, so a little more detail about the features under consideration. Moving from 160 megahertz bandwidth to 320, a multi-band or channel aggregation and operation, and then more coordination between access points. And basically continued improvement on features that are introduced in 11ax. I want to talk briefly about additional spectrum and the work that's going on in 6 gigahertz. There are efforts underway to obtain additional spectrum, specifically in 6 gigahertz, to support for Wi-Fi and unlicensed operation. And there was a study done by the Wi-Fi Alliance, the link is here, a Wi-Fi Alliance spectrum needs study that identified the anticipated growth in data throughput needs and the shortfall between the existing spectrum that we have and what would be needed to meet those needs. So this has led to the global regulatory advocacy that's currently underway to try and get additional spectrum allocated. There's activity in the US with the FCC, in Europe, discussions underway with really across organizations globally, including APAC. So here's a visualization of the study of the bands that are currently under study, the bands and channelizations for the US and Europe. You can see that in the US they're considering from 5925 to 7125, with just the first part being under consideration in the EU. So there are a lot of studies, discussions, et cetera, underway to look at how can we really, it's a higher level policy question. You know, I will digress momentarily, but a regulator, what really is the job of a regulator? A regulator is to make the best use of the spectrum for the population, right? Especially unlicensed spectrum, right? It's a community resource, it's a national resource that's controlled within a certain boundary. And so how do you use that spectrum for the maximum benefit, you know, of your citizens and the population that is present? So currently there are incumbents in the 6 gigahertz bands, primarily for fixed wireless services. And so the work underway is to look at how can those incumbents remain and be unaffected by additional use of the spectrum by unlicensed wireless LANs. And so that is the topic of technical discussion. You know, we acknowledge the incumbents and the necessity to protect them, and believe that low power operation, particularly indoors, can be had while still protecting the incumbents. Okay. Can somebody, I apologize, tell me how I'm doing on time? 10 more minutes? Okay. 10 more minutes and then Q&A. That should be good. So let's switch from 2.45 discussions with AX and its evolution eventually to BE, and talk about 60 gigahertz. So 60 gigahertz, the initial standard that we had for 60 gigahertz was published in 2012. And folks at that time had very optimistic views of when products would hit the market. And there was a lot of learning that was had to realize that building these 60 gigahertz systems really is more complex than was initially envisioned. So although the standard was published in 2012, products now are starting to come on the market. So the data rates that are supported in 60 gigahertz range from at MCS1, the lowest rate, 385 megabits per second, going all the way up to 8 gigabits at the highest MCS. So you see that even at moderate MCSs, you can get 1 to 2 gigabits of throughput on a 60 gigahertz system. So the products in the marketplace today are primarily point-to-point products. And although there are some client devices, wireless docking stations, et cetera. We have work underway to extend the 60 gigahertz throughput in the 11AD project. But I'd like to focus first on a use case that really is driving adoption of 60 gigahertz, particularly for fixed wireless. So the use case is, we'll say, fixed wireless at an affordable, very low cost 5G performance. This is a quote, the source is provided here. It says 14 gigahertz of continuous spectrum in the band offers more bandwidth than any other licensed or unlicensed millimeter wave band. 60 gigahertz band has chipsets on the market. The bottom line of this opinion was that This makes the 60 gigahertz band an excellent alternative to licensed millimeter wave frequencies for smaller providers, as it can be used to deliver 5G performance for the minimal cost of available, in our case, 802.11 60 gigahertz infrastructure products. There are actually deployments and test trials of these systems today across a variety of geographies. So when we talk about, keep this in mind, when we talk about the evolution and how .11 systems will support the vision of providing, the 5G service vision to customers globally, right? Not every fixed wireless system will need to be deployed in a licensed spectrum. We can do that in unlicensed too, at a much more affordable cost. Okay, similarly, here's the example of mesh backhaul and wireless. So this is basically Facebook has a number of trials with their Telegraph system, which is 60 gigahertz fixed wireless backhaul with mesh. The website link has some examples of the places where they've trialed this. Again, to get internet, reach internet, enable internet to be provided to those who previously did not have access. Okay. Picture of the 60 gigahertz spectrum worldwide. Basically, various countries you have some or all of the 57 to 71 gigahertz available for unlicensed use. And then what we're doing for an extension here is in 11AY, looking for, again, continuous improvement in throughput and range in those 60 gigahertz systems. Here, the goal is to have a 20 gigabit per second rate mode defined, where you saw in 11AD, the range went up to 8 gigabits per second. Now we'll go up to 20. Address the license exempt bands and be able to operate there. They may complete in 2020. It might move out to 2021. The first chipsets have been announced. And so you can see the set of use cases that are identified here. Okay, and here are some of the techniques. Channel bonding and aggregation and a single user and downlink multi-user MIMO are introduced. So again, the technology comes in to further provide the performance that's required. Performance comes in over time, the technology comes in over time. So that's AY and that's AY. So then we'll talk about BD, 811 BD, and then we'll talk about a little more about 5G. So we are defining a next evolution for V2X based of 11P. 11P was based largely on 11A. 11A is the first standard that was defined for 5 gigahertz back in 1999. It is astounding to me how robust, efficient, and how this standard has stood the test of time, in particular some of the mechanisms that were introduced. So 11P is a very simple technology, right? And so our goal is to provide enhancements that were introduced subsequently from 11ACAX and have a backwards compatible next generation V2X standard. So you can see in the little puzzle here, the goals are longer range, higher throughput, backwards compatibility, and support for positioning. Positioning being like ranging and location type applications. This is very doable, higher throughput, modifications in the OFDM frame design, extensions, backwards compatible extensions to it, increased MCS, changes in the coding, and packet aggregation will basically get you there. Longer range, the mid-amble design, repeated transmissions, more robust channel coding. So this group is underway. They're making very good progress. And I want to just emphasize the backwards compatible nature of this standard so that all of your existing devices continue to work. It's not a forklift upgrade of the entire system to accomplish the evolution. Okay, and then the use cases that are being targeted, 5.9 completion in 2021. There are key additions, twice the throughput, longer range, etc. We covered those. Some of the use cases are listed here that have been discussed. Okay, so that's that. So now let's talk about how .11 is essential to supporting the 5G service vision. As I mentioned, I get this question quite a lot. 5G, 5G, 5G. Yes, 5G. 5G is great. 5G is wonderful. 5G has multiple definitions. If we look at how are .11 technologies used in today's operator infrastructure, basically today's 4G networks, setting aside 5G for the moment, today's 4G networks include .11 technologies, primarily for offload and for Wi-Fi calling. These are use cases that are deployed across numerous operators today. Why? To meet customer demand for data throughput and increase coverage areas where you can't necessarily, deploy the licensed spectrum cost effectively. From the Cisco VNI, more traffic was offloaded from cellular networks onto Wi-Fi than remained on cellular networks in 2016. There are charts that show how this is anticipated to change over time. The bottom line is .11 is still essential for carrying this traffic. Depending on the country, you can look up the statistics, between 50 and 80% of the public and private internet traffic is carried on Wi-Fi. So that's the situation today. What has happened on the 3GPP standard specification front is that 5G radio aggregation technologies natively incorporate non-3GPP RANs. So a .11 radio access network can interface to the 5G core just as a 3GPP defined RAN would. Okay, that's a very important evolution in the way of in the standard of 3GPP. If you look at least the way I think of 5G networks, there are two components that change over 4G. One is the radio evolution. The second is the core evolution. The core evolution is moving these telecom infrastructure networks more to a computing technology model rather than a customized telecom model, right? So they're talking about network slicing and virtualization, and these terms that have been around in computing and data center networking for a long time, right? But now, how do you move a custom application like telecom to that more general model? That's what's happening in the network side of the evolution, okay? On the radio side, there are enhancements in new radio, NR, and NRU, and the definition of NRU. So the radio is likewise being enhanced, but the system is being modified so that the interface of the radio to the core system is now really uniform across the PHY types and the radio types. So we see that 11AX, 11AY, and to some extent 11AH will be, can be leveraged and interfaced to those new cores to help provide and meet the service vision. Okay. I mentioned at the beginning that in 802.11 we had that advanced access network interface group that was working. And one of the essential pieces of work that they have done is to carry out simulations and analysis to identify the extent to which 802.11ax, and they looked specifically at draft 3.0, draft 4.0 may have additional enhancements, the extent to which the 11ax, MAC, and PHY meet the 5G requirements for specific 5G indoor use cases. So for example, we've looked at the 5G indoor hotspot use case. So this is the IMT 2020 defined indoor hotspot use case. In this use case, there are a number of parameters that if a system meets these parameters, meets the various levels, it will provide the performance that's expected of a 5G system. So the analysis has been done, and we've confirmed that the performance of the 11AX MAC and PHY meet or exceed the 5G requirements for the 5G indoor hotspot use case. All right? This is really quite a validation of the work that we've done, that you can deploy your frugal 5G with Wi-Fi, and the customers will get the same performance level that they would get on a licensed 5G system. That's really pretty amazing. It's a very, it's a notable accomplishment, I think, and I applaud our engineers and designers. So the link is provided here, the document 1119-1284, which is the summary of this analysis that was done. The analysis has now been completed for both dense urban and indoor hotspot, and the result is the same. So, I'm very proud of this result, and I want to acknowledge the engineers who completed this result. They're actually based in Bangalore. Sindhu Verma and Shubhadeep Adhikari, who did this work. There are others too, but they've done, yeah, we can clap for them, definitely. Okay, so this is the requirements piece. So AX meets those requirements. It meets the 5G indoor hotspot, dense urban, and we're starting to look at other use cases, meets those requirements. That's the performance piece. The second piece is that Wi-Fi is a pure radio access technology in a 5G system. So starting with release 16, I don't have the time to go through the details here, but the 5G core in the new definition becomes radio access agnostic. Okay, so you can get an end device can register, can get the access to the 5G services without having to have license-based access. And I think this gives tremendous flexibility to an operator to deploy the radio access technology that makes sense for them based on their economic need. So they can actually deploy a lower cost system by leveraging the 802.11 components. So in summary to answer the 5G question that people ask, I believe that .11 and cellular licensed radio technologies are largely complementary in meeting the comprehensive 5G service vision, right? The service vision of 5G is exceptionally broad, providing very high bandwidth or, the connectivity needs of the world for the future, right? And so I believe that both are required. There's the wireless LAN piece, which has its particular strengths. There's the cellular piece, which has its strengths, and both are needed. They're complementary. And so we will continue to evolve the .11 technology to meet more and more of these use cases, enabling further deployment and meeting our end users' needs. Okay, so that's that. I think I'll stop now if we're at time. I just want you to know that you will have this presentation deck. There's additional material here that I did not have a chance to go through. I'll call your attention to just like one sentence on each item. 11AH, which is sub 1 gigahertz operation. 11AZ, the second generation positioning features. Wake up radio, 11BA. Light communications, which you heard a lot about yesterday. And then 11BC, which is enhanced broadcast service. This last one, 11BC, is an example of a project being started within .11 by a set of engineers who saw some use cases. And then we started the project, and lo and behold, who shows up at the doorstep but some folks from the technical research area of the BBC who said, "This is great. We're so glad you're starting to look at this. We've been looking at this in our lab. How can we use a deployed .11 system to extend the reach extend access to people who currently don't have it. So the innovation comes from many places, and I'm continually astounded at the uses and the applications that end users have found for .11 systems. And I encourage the CDOT folks. I'm delighted that to see the Wi-Fi based products that you've built, and I'm sure will be used to the benefit of the country. I encourage you to continue innovating using .11 technologies, and of course, encourage you also to participate in the standards development process. So I thank you very much for your time and attention, and I guess we'll move now to the questions. Thank you.
Do we have any questions? Yeah, we have a question from there.
So we were hearing that IEEE will submit a separate writ at ITU. Right. So, but looks like this technology that you have, the convergence with 5G, you're submitting it into release 16 at 3GPP now. So your solution of using Wi-Fi in the radio access network will be incorporated into release 16.
Okay, excellent question. So there are really two parts. I'll answer the question in two parts. First, we are not submitting .11 as a writ into IMT 2020. The possibility of doing that was discussed long and hard by the participants. And at the end of the day, the decision was that we don't need it. We don't need that stamp on our standard. And there are two reasons why we don't need it. One, we have good market adoption. Right? All right? It was unclear the benefit that stamp would provide. We have market adoption, and the process that's set up for having a writ adopted is really so geared to the cellular world. It's built and defined and managed by the cellular operators. And so there's a lot of work that would be required to go through that process. The decision was it's a better use of our resources to continue to develop our technology. And then the other point was the lost my other point.
The 3GPP release 16.
Yes. So we don't need to submit our technology to 3GPP. The way that the specification that 3GPP is defined is there is a radio access interface defined, and as long as we meet that interface, we're fine. There's been a lot of work done to define that interface in a way that enables non-3GPP defined RANs to interface to the core. So we just need to meet the interface that has been defined. We don't have to actually become part of that standard. Okay, I think this works similarly with other PHY standards that might be out there. As long as you meet the interface to that 5G core, then the services and the user interactions with the core will be supported.
Considering the paucity of time, we'll only have one more question. So we can have it from there.
So, this non-3GPP Wi-Fi access network, the provision did exist even for the 4G. And I'm sure even just after release 5 of 3G plus itself, these provisions did exist. But not really this thing got into the practice, possibly some industry reasons for this. But I want to draw your attention for the discussion we had yesterday is what we actually need is multi-operator core network interface at non-3GPP Wi-Fi access network. So if you do that, then it becomes a solution for public Wi-Fi catering for multiple operator scenarios. Possibly, I want to see your reaction on that.
Okay, multi-operator use of a shared Wi-Fi network. I'm not completely clear on the question. I think there are examples today of Wi-Fi networks that are used for a single operator. You can develop a system where you are offering effectively a shared access system. Okay, I think a lot of the work that has been done for authentication mechanisms has been done in the view that there's a single authentication entity. And systems that have been successful, like EduRoam, and I think I may have mentioned that to someone yesterday. You know, EduRoam is an organization that provides authentication of for educational institutions. So you have a professor from one university goes to another university, and if they're all in the EduRoam system, you get on the Wi-Fi network automatically. And that's done by having a series of radius-based, IETF radius-based authentications. You have a home server, visit server, et cetera. The assumption underneath that makes that system work is that you have an entity, each university, that's willing to stand up a radius server. What do you do when the network operators, so your various public Wi-Fi operators, aren't willing to stand up that service? So now you need to have another entity that steps in and provides that. And I think there's a lot of work going on in the EU right now, the Wi-Fi for EU initiative, where the EU is basically giving grants to municipalities and villages, et cetera, with the goal of deploying Wi-Fi networks so that the population has free access to Wi-Fi networks. It's kind of a basic level of, a utility. That's a right that people have. I don't know about right, but it's something that they want people to have. So they're looking now at what should the authentication mechanism be. So I'm interested to follow that. What path do they go down with that? And I think there's probably investigation going on here also. That area of network management and management of multiple networks is not the primary focus of .11. We focus on MAC and PHY, right? But if there's a problem statement that comes to us that we can work on, absolutely have the conversation.
Thank you, ma'am. We appreciate the inquisitiveness of the audience here, but considering the time constraints, we will have to conclude the session here. Thank you, ma'am, for your enriching talk, giving a meticulous account of the evolution of 802.11 standards to Wi-Fi 6 and beyond. May I now request Mr. Vipin Tyagi, Executive Director CDOT, to present a token of thanks and gratitude to Ms. Dorothy Stanley, IEEE 802.11 Working Group Chair. So we have our director, Mr. Jayant Bhatnagar, presenting a token of thanks and gratitude to Ms. Dorothy Stanley, IEEE 802.11 Working Group Chair.
I want to add something, I am compelled to add something. I'm sorry, I'm breaching the protocol. One of the best presentations today. And thanks, Dorothy, for coming here. But the things that I wanted to tell you, India is experimenting with the Wi-Fi in a very, very big way. Probably the biggest in the world. 560 megahertz spectrum has been allocated, which is highest in the world in here. Also, a framework called WANI, W-A-N-I, has been created for mobility across the hotspots. And this has been tested. The product that you see outside, all Wi-Fi are WANI compliant. Next thing, it means that you buy the subscription of one hotspot and you can roam around in the entire country. Also, another thing which is happening here is that we are couponing the Wi-Fi. It means that you can buy based on the time, prepaid, and then you can roam around. You are going to railway station to another railway station. The same coupon that I have bought for a particular value will continue to be servicing the business model. Another thing that is happening here is that we are probably the first one in 2009 or 10. When Obama came here, we had the video conferencing over the Wi-Fi on outdoor. And the place was about 200 kilometers away from here. So it's a lot of experimentation is going on here from India. One more thing that we are proposing is that, like cellular broadcast, you can broadcast the messages to people who are affected by the flood or something. We have implemented that in the Wi-Fi, and it is called Common Alert Protocol, CAP compliant. That has been done by CDOT into the Wi-Fi hotspots to save lives for the people. Other than that, I can go on, but I think your presentation actually excited everybody and brought about the 5G and all of that together. So must thank you on behalf of everybody one more time. We will work very closely with the IEEE 802.11 to implement whatever is coming there.
Okay,
thank you.
We'll take care of it.
Thank you, sir. Ladies and gentlemen, we shall now have a tea break for 20 minutes. I request you all to please adhere to the time limits and reassemble here for the next session.